Here's the type of quadratic we run into that typically gives us a little bit of issues. Now, there's a host of ways of solving these. I learned by just figure it out. No real method. You may have learned the diamond method. And I'm about to do something that's kind of the diamond method hidden. You are under no obligation to learn how to do this, understand this, or even watch this stupid freaking video. This is a trick that I use. It's a trick. I'm not really going to explain it. I'll explain how to do it. I'm not really going to explain why it works, but it works. It gives us a process rather than a guess and check. I hate guess and check. A student taught me this. Actually stopped me in the middle of the class and said, your method sucks. Let me show you a trick. And I've been using it ever since. But there's a lot of little tripping points that go along the way. And the first time you see it, it's not simple. But throughout my videos, I will show it again and again and again. You'll probably see me do it about 5 or 6 times throughout all the lecture videos. So if you don't catch it this time, maybe you catch it the next. All right, here it is. This type of problem I'm talking about. It's this dang leading coefficient. So whether there's an equal 0 or not, like, hey, just factor that thing up. That's an issue, right? We typically don't struggle too bad if there's no leading coefficient. We find those two numbers multiplied together to equal the final term, and then the sum of them are to equal the center, the b. But on this one, it's no such luck. We have that dang 6 hanging out there, which is going to make things a lot more challenging. So if we were to go and want to solve this, there's many tactics. I mean, you could just do the guess and check. This is what old Miss Spiliotis, I think that's who taught me how to do this. All I remember, she used to yell at me a lot. Like a lot. Yeah, she said just figure it out. It's got to be two numbers, so there's going to be like a 6 and a 1, or a 3 and a 2, and then you got to figure out what numbers with a -4. You can guess and check, and that's a perfectly valid method. I'm just going to show a little bit different a way of solving this. Now, I'm going to do a trick. It's like an algorithm. It's not going to be equal in the meantime. So what I'm going to do is, since this thing is equal to 0, I'm going to write it off to the side. And I'm going to say 6x squared plus 5x minus 4. Not equal, because in the meantime, until we get to the end, it's not going to be equal. I'm going to just start doing a process down. And it's not going to be equal to what we started with. It's a trick. So the way it's going to start off is we're going to say, you know what, that 6 sucks. I hate that 6. I wish it wasn't there. So we're like, okay. Bring it over here and just multiply by -4. So we're like, all right, x squared plus 5x. Now what's 6 times -4? Isn't that -24? All right, chill. Chill. Now factor that. Just factor that. Now this isn't going to be our answer, but factor it. Two numbers multiplied together that equal -24. And sum to be +5. Well, I'm thinking, what, +8 and -3, right? Because 8 times -3 is equal to -24, and 8 minus 3 is equal to +5. Well, that can't be the answer. There needs to be something, right? There needs to be some numbers here. That can't be the answer. So here's the trick, is once it's factored, remember that thing that you brought over and you multiplied, now we're going to bring it down, and it's going to become the denominator. That 6, whatever you started with, is the denominator of each. And we're almost home free. We will reduce our fraction. Half of 8 is 4. Half of 6 is 3. 3 over 6, I think that's a half. Now this is still not the answer, but we're damn near there. Take your 3 and bring it up. Take the 2 and bring it up. And we end up with 3x plus 4. And that's going to become a 2x minus 1. And that's the weird uncle trick. Got to see it a few times. Most of my students use it pretty well after a while of watching it. Now, you can't do it. Like if this was, say this 5 was going to be a 2. You couldn't do it because 6, 2, and 4 have something in common. You can't have anything in common. You can't factor anything out at the beginning or this algorithm will break down. So once we're here, we can now do our zero product principle. go through and solve. And we're going to get that x is equal to -4/3. I'm going to jump my steps. And x is equal to 1/2. And those would be the two solutions for our quadratic. By the way, for those of y'all that like patterns, just thought I'd throw it in there. Just thought I'd just take it or leave it. So there it is. There's the word uncle trick. Did it once. The next ones we're going to do, we're not going to factor. We're going to use, so we'll talk about the quadratic formula and completing the square. See ya.